Now, in order to do it, we introduced the unit step function. Remember, when we did it, it was a nice function. Okay, this is the unit step function. We divided UCT. There's going to be base. Base is a C. C is a positive number. So we partition it around the C. T less than the value of the function is 0 when t is less than C. 1 when t is greater than C. This is called UCT. Sometimes if you like to switch 0 and 1, start with the 1, then go to the 0, you have to consider the complement of this function. Okay? The complement of this function would be 1 minus UCT. I'm going to show you where we are going to use it. Now, what we did the other day, we just show you how we can connect it with other function, but eventually we find the Laplace transform of the UCT, e to the negative CS over S. So from now on, as soon as you see this expression, because you are going to use it for the Laplace inverse, because you want to solve equation first. So anywhere you will see this expression, you will find out that there is going to be unit step, okay, unit function around. Then I gave you this theorem that we just introduced this theorem that we're going to continue today. Okay, we call this one translation theorem, okay, or shifting if you like. So this is the format that we are going to have. You have the UCT, which is unit step function, but this is going to be f function, but we consider f of t minus c. You know, then you shift it to the left if you like. C units, t minus c. If you want to find the Laplace transform of this function, this is going to be your result. E to the negative st f of t, but in the inverse form is the one that we're going to use, okay? So in the inverse format, if you are going to be given a function of this form, okay, the function of this form that you see this e to the negative cs, you will find out this must be related to the unit step function. So what I'm going to do, I'm going to give a couple of examples. The problem is going to be finding this, mostly the inverse of this, and then we are going to take it, how we're going to use it when you are going to be in a situation of the, okay, solving a differential equation. Okay, so let's go for it. This is it. So we are going to see what is the application of the so-called translation, or first translation. We call it translation because we change the t to the negative t. Okay, so I'm going to give you an example on this one. I write this formula again so that this is the way we're going to use it. So this is our translation. Okay, this is the translation theorem. Okay, now if you see it somewhere, we will find out what we are talking about. So this means the Laplace of UCT f of t minus c, when you shift it, it's going to be simply e to the negative cs, e to the negative cs, sorry, e to the negative cs, Laplace of f of t. Okay, which is the same as Laplace of UCT f of t minus c. Is simply because of the UCT, you have the factor of e to the negative cs. Okay, again, I missed it. CS, but times it by f of s. Okay, equivalently, the Laplace inverse. Equivalently, as soon as you want to find the Laplace inverse of this function, e to the negative cs, okay, cs fs. Because of the e to the negative cs, you are going to have a UCT. UCT. Okay, UCT f of t minus c. So this means you are going to find the Laplace of this function first, okay? But you change the t into the t minus c. Let me show you how we're going to apply it. So we give you one problem. It's going to be two parts independently. The first one, you want to find the Laplace transform of each function. Find the Laplace transform
of each function. This would happen when you want to solve the equation. Okay, the first one is this function. F of t equal to the t minus 1 of t, okay, minus 2 times t minus 2 u2 of t plus t minus 3 u3 of t. You see, you are not going to multiply, simplify, nothing. Just look at these terms that you have. You see, this is u1 of t. This is t minus 1. It's like this is u1 of t. This is like f of t minus 1. So what is f of t? This one. If f of t minus 1 is t minus 1, what is f of t? Okay, this is f of t minus 1. If you want to find f of t minus 1 is equal to the t minus 1. Okay, f of z is equal to z. So what is f of t? T. Okay, this is the one. This is f of t minus 1. So if you add 1 to this, that should give you the function because you shift it. You shift it to the, because you have to find that function to be able to get the Laplace inverse for us. Okay, the next one, t minus 2 u2t. Again, you can use that translation that we talked. Look, see, we compare it with the top that we have. You see, compare it with the top. So if you want to find the Laplace inverse of this one, it's going to be equal to what? E to the negative cs. C is 1. E to the negative s times the Laplace of f of t. This is t minus 1. So the function is t times the Laplace of t. This would be negative 2. Since you have u2, it's going to be e to the negative 2s. Negative 2s Laplace of f of t. This is f of t minus 2. So again, it's going to be Laplace of t. This is u3 e to the negative 3s. Laplace of f of t, which is t again. Okay, so don't multiply it. If you multiply it together, some people say, I'm going to multiply it and I do it again. Okay, no, you just do it as is. It's nicely given to you. So this is how you identify that. You have to use that translation theorem. Okay, so this is the way you write it. I explain it for you. Okay, that's it. So Laplace of, this is it, Laplace f of t. You know that it's linear, so you break it. It's going to be Laplace of. Okay, if you don't like this, you can move it, switch it. It doesn't matter. So the first one is like, this is like, if you like to write it on this form, u1t times t minus 1. The next one is minus 2 u2t times t minus 2. The last one is plus Laplace of u3t times t minus, okay, times t minus 2. Okay, now for each one of them, one by one, you apply the translation theorem. This is going to be equal to, you have u1t, so it's going to be e to the negative cs, e to the negative s. Laplace of f of t. You see, this is t minus 1. If you add the 1 to it, that gives you t. So it's going to be Laplace of t. Your function is t, then t minus 1 is going to be f of t minus 1 will be t minus 1. Minus 2, the base is 2, e to the negative 2s. Laplace of, you see, this is f of t minus 2. You add 2 to it, so that gives you Laplace of t. And the last one is going to be plus e to the negative 3s. Again, Laplace of t. Any question? Now you know that the Laplace of t is what? Laplace t is 1 over s squared. So each one of them would be So this is going to be e to the negative s squared minus 2e to the negative 2s, again s squared, plus e to the negative 3s, again s squared. Since all the numbers are the same, so you better write it down as s squared. The top would be e to the negative s minus 2e to the negative 2s plus e to the negative 3s. That's it. So that would be the Laplace of the f of t. And any question? Yes.
Why is it all over s squared?
Because the Laplace of t is 1 over t squared. Then you have to multiply by those factors, okay? So Laplace of t is 1 over s squared. Okay, so all those coefficients are going to be divided by s squared, divided by s squared. It's going to be these times 1 over s squared, e to the negative s over s squared, 2e to the negative 2s over s squared, etc. Any question? That's type 1, everything nice, okay? I don't expect to have this all the time. So the next one is you have to do something yourself to make it nice. Okay, are you ready?
Wait, no.
Next one, so repeat to do. Let's see if we find out how we're going to do it. F of t equal to t minus 3. T minus 3, look at this, u2t minus t minus 2, u3t. Look at this one. So look at the base. You see the base is 2. This is u2t. So over here, you must have what? For your function, if you like, you see, you have to write this one in terms of the 2 to be able to do it. Okay, we can guess what is going to be your function. This is the base is 3. There are different ways to do it. One way to do it is this one. Break it. You may have to add, subtract something. So we rewrite it as f of t equal to, work on this first one. You would like this to be t minus 2. So what you can do is, I like t minus 2. Okay, t minus 2. So what I do is, I'm going to add 2, just no different, you can do it right away. I'm going to add the 2 to get t minus 2, then subtract and add 2. 2 minus 2, minus 3. u2t. You see now I have t minus 2. These two would be added together. Then you can write it down in terms of f of t minus 2. Here I need t minus 3. So I'm going to write this one as t minus 3 that I like. But I have to add the 3, and there is a 2 here. So that gives me u32. So what do you have? So I'm going to have, this is it. I'm going to have a t minus 2 minus 1, u2t. Then this one is what? This one is t minus 3 plus 1, ut3. You see that give me a better idea of what is going to be the function f of t to be able to do it. Okay, this is utt. This is going to be, okay, this is going to be utt. And this is going to be f of t minus 2. If f of t minus 2 is going to be t minus 2 minus 1, you replace the t minus 2 by z. So f of z would be z minus 1. So f of t would be t minus 1. It's like a you're just replacing the t by t minus 2 over here. So this would give you t minus 1 as a function. Over here is going to be the same thing. T minus 3, you call it t minus 3z. So you have z plus 1. So the function over here is going to be z plus 1, which is t plus 1. And the function over here is going to be z minus 1, which is t minus 1. Okay? So this is it. What is going to be the Laplace of f of t? You shift it, okay? You shift it 2 units. So Laplace of f of t is going to be the Laplace of, right? Rewrite it, the first one, u2t times the function t minus 2 minus t minus Laplace of u3t times t minus 3 plus 1. You see, the result would be what? You have a unit step function with the base 2, so this would be e to the negative 2s. Now, f of t minus 2. You see, this is the Laplace of f of t. So you think about this one, t, so that give you the function that we're going to have is going to be t plus 1. So it's going to be times Laplace of, okay, times what? Times the Laplace of t plus 1 for this one. Okay, so that is going to be the way I did it over here. We can do it as is, or the way I did it on my notes. You know, if you want a little bit more, I can do it with the Laplace of t minus 1 over here. Or what you can do is you can multiply them together. If you don't like this one, you see, if you multiply them together, this first one is exactly like the one that we did. It's going to be u to the 2s Laplace of t. Then minus what? Minus u2t. Then you can take that ut2. I do both methods. So then you can try it, you can check to see which one do you like. Okay, so the first choice is going to be Laplace of t minus 1. Okay, this is going to be minus e to the negative c, negative 3s. Then again, this is going to be what? This is going to be Laplace of t plus 1. Okay, this is one way to do it. Now Laplace of t minus 1, you can find it right away. What's the Laplace of t minus 1? I'll go to the next page, continue. I find the Laplace of t minus 1. Laplace of t is 1 over s squared. Laplace of 1 is 1 over s. Then the other one would be exactly the same thing. So then I give you the other method you see. So this is going to be equal to, to just show you. You see the Laplace of t minus 1 would be what? 1s squared minus 1s. And Laplace of t plus 1. T plus 1. T plus 1 again is going to be 1 over s squared minus s. So go back to your function. What's going to be f of t now? F of t is equal to, it was e to the negative 2s, e to the negative 2s, now times this. 1 over s squared minus 1 over s. Okay? It was minus e to the negative 3s times 1 over s squared minus 1 over s. So if you put them all together, what's going to be the final answer? The final answer is e to the negative 2s s squared minus e to the negative 2s s minus e to the negative 3s s squared plus e to the negative 3s s. So that gives you Laplace of f of t in general. Any question? Yes.
Why is the Laplace of t minus 1 and the Laplace of t plus 1 the same? Or like how is it
They're not the same.
1 over
There
s?
is a sign in between. This is plus. Okay, so the last one would be. Okay? Because there is only negative sign in between. The difference. This is one way to do it. I can show you another one. You can pick the one they like. But, you know, this is a straightforward. The method in my notes that I'm going to post it for you. You see the method 2? Some people like this one. And this is quick. So let's go back to what we did. You see, you did have this one. You have your function is f of t. I repeat it again. You know, after a while, you get used to it, and you can do it with this method. You see, this is a t minus 2 that we created, minus 1 times u2t And that was minus t minus 3. Last one times ut3. See, the other method is that you like only t minus 2 times u2. Multiply them together. If you multiply them together, that gives what? T minus 2 u2t minus u2t. You multiply this one minus t minus 3 ut3t minus u3t. You see? Now this is more standard for you. It's like the previous one that we did. So what's going to be Laplace of f of t now? Laplace of f of t. It's going to be Laplace of the first one. You see this one? This is a standard because u2t that give you e to the negative 2s. And this would be the Laplace of t only because t minus 2, okay? Laplace of t. Laplace of u2t is unit step function. Laplace of unit step function e to the negative 2s over s. Minus, this is u3, so that give you what? E to the negative 3s times Laplace of t. And the last one is a unit step function, u3t, e to the negative 3s over s. That's it. Laplace of t is 1 over s squared minus e to the negative 2s over s. Again, this is s squared. Okay. And the last one is going to be what? Minus e to the negative 3s over s. If you compare them together, same solution. So you pick the one that you feel more comfortable. You have to write that shifting part is important. If you have a u2t, you have to have f of t minus 2. If you have u3t, you must have the u, okay, t minus 3. In the second method, the leftover, I just pull them out. But in the first one, it's the same thing. It's a function. In the second part, I use the function t, but in the first part, I use the function t plus 1, t minus 1. And both of them give you the same answer. So you can pick the one that you like. And you are going to have it. You will see when you get to the solving differential equation you have. Okay, any question? Yes.
How did you do like that first part where it was like t minus 2 u2t? Like
The
how did
first
you
one?
get e to the negative 2s is times? No, for the first part.
This one?
Laplace. No, if you go down on the current problem we're on.
This one?
Yeah. On like the left, the first term, it was e to the negative 2s. Laplace of t. Yeah.
The theorem. You see the
Okay.
theorem is what? F of t minus c uct. F of t. What is your f of t? F of t is t. Laplace of t. You see, t minus 3 u3t. What is your function t?
And then what did you do with the Laplace of, oh, it's the Laplace of t, not f of t.
Yeah, t.
Okay.
This is in fact f of t in the formula. But your f of t here is t.
Okay.
You see, it's a name. T minus 2, call it z. See, t minus 2 is z. So f of z is z. So what is f of t? T. You see the way you do it, it's going to be always the same. You're just shifting the function. Yes.
Can you repeat what you said the theorem was? It's like you take the, yes.
You see, that's the theorem.
Yeah.
Look at the theorem.
Oh.
You see, in order to apply this theorem, the quantity must be what? UCT f of t minus c. CC. If you have a CC, drop the C. That gives you f of t. You just find in the Laplace of f of t all the time. So I have t minus 3, I drop the 3. Function is t. See, I have t minus 2, I drop the 2. Function of t. But you have to arrange it. You see, you have to have, in this problem, there was a leftover. That was a difficulty. You see the problem that we have. Look at this one. This last problem. This last problem. You see, that problem was easy. T minus 1t, drop the 1, Laplace of t. T minus 2 ut, drop the 2, Laplace of t, Laplace of t. But the difficulty for this one is this. Look at this one. you have t minus 3 and 2. So if it is t minus 2, you can make it. You can make it yourself because you shifted 2 units. So get the 2 back to the function. You have t minus 3. If you get the 2 back, the function is t minus 1. Over here is t minus 2. You shifted 3 units. Get back the 3 to the function. The function is t minus 1. You can do it quickly. But the way I did it, I arranged it so that you have the same thing like this. You see, this is 2, so I break it to the t minus 2. You see, I break it to t minus 2, u2, t minus 3, u3. Okay? So the function, if you drop the 1, the function is, if you drop the 2, the function would be t minus 1, t plus 1. You see, you can do it. This is algebra, this part. Doing this shifting to put it, to put it together. That's very useful. We practice. Any question? Yes.
Can you go back to that theorem, please, one more time?
What that?
Could you back to that theorem, please, one more time?
Theorem just here.
Yes.
You see, it's basically this means if you shift the function, you see your function f of t, you shift it. If you have a UCT, you have to shift the function, okay, to the left. Or to the right, sorry, to the right. And say t minus c is to the right. So it must be consistent to be able to do it. It's too easy because it's a TT, you are a little bit confused. Well, you see, the names are not important. The function is the machine, the action is important. Okay, so let's give another one to see the real one. Okay, how about this one? You have to be able, to get ourselves familiar because you have to do it in one differential equation. Okay, how about this one? This is nice. I have 2 nice for it. In your book, you get a group of this. Okay, you have quite a lot. And so let's see if we can do this one. This is lots of fun, okay? Let's see who can do it. T less than 2, t minus all squared, t greater than or equal to 2. You see, that's your function. And of course, we want to find the Laplace of this function. Laplace of f of t. Of course, one way to do it is definition. Like they did on the quiz. If you want to do the definition, you have to break the integral from what? You break integral from 0 to 2, 2 to infinity. 0 to 2 with the 0, then you end up with this one. T minus 2 squared e to the negative st dt, and you have to use integration by parts, and eventually you'll be able to find it. But you can do it quickly with the unit step function. In order to do the unit step function, you have to change it to the unit step function. Okay, let's see how we're going to change this one into the unit step function. Remember, the definition of unit step function is 0, 1. You already got the 0 here. So you have to make this one 1. Any suggestion? I'm going to make this one 1. F of t equal to, you factor up, you divide it, if you like, t minus 2 squared. So we can write this one as what? T minus 2 squared times this function. 0 on the top, t less than 2. You see, because if you multiply t minus 2 squared times 0, that gives 0. So we haven't done anything wrong. Then 1 here, 1 here, 1 here. Okay? Now, if you multiply by the top one, that gives you 0. If you multiply by the bottom one, that gives you a function. 0, 1. What is this function? You have a unit step function at the base 2. So this will be equal to f of t equal to t minus 2 all squared, you see, u to t. And have exactly the format that you are interested in. Doesn't matter, you can switch it if you like, But that's it. We can apply the theorem. You see the C is 2 now. The C is 2. Look at the theorem that we have. Look at the one. This is the theorem that you're going to use. UCT f of t minus c. You know, if you like, I can switch it so that you can see it exactly as we did over there. You see you have the u2t times t minus 2 squared. That's it. So the Laplace of f of t would be, because of the u2, give you u e to the 2s. 2s, Laplace of the function. But remember, this is t minus 2. Drop the t minus 2, call it z. It's like z squared. So your function is t squared. Okay, so you have to find the Laplace of t squared. That's it. Okay, because this is what? This is f of t minus 2. So your action of the function is what? It's just a square function. F of t equal to the t squared. So f of t minus 2 would be what? T minus 2 squared. Any question? What's the Laplace of t squared?
6, no, 2,
2 factorial,
yeah,
which is
2
2, 1 up is 3, n plus 1, remember? Laplace of, we're using this Laplace of t to the n is what? Is n factorial over s to the n plus 1. That's it. So the Laplace of f of t is simply 2e to the negative 2s over s3. See, imagine if you want to use definition, t minus 2 squared e to the negative st dt, integration by parts. Takes ages. Okay, so this is the way you break it into parts, but make sure that your function, you see, match the theorem. Match the theorem. 2, 2, nice. 2, 2. What is the action of the theorem of function? Is squaring function. So it's a t squared function. Okay, any question? Want another one? This next one. If you check any differential equation, both textbook, you will see this too, especially this next one. It's going to be all over the places. Let's see what's special about this one. The function is f of t. F of t equal to, how about this? 0. If t is less than 1. This is going to be t squared minus 2t plus 2 when t is greater than or equal to 1. Need algebra to be able to do it. Of course, one method is definition. Just imagine if you use integration by parts, you have to do, t squared e to the negative t, etc. Now the unit, the step function. Again, change it to unit, the step function. Now you get the idea how we do it. You have the 0, you factor this one out, okay? So rewrite it, solution. F of t equal to, we factor this one out, t squared minus 2t minus 2 times it by 0, 1, t less than 1, t greater than or equal to 1. Quickly, this would be u1t. Okay, unit the step function, 0, 1 at the base. Yes?
Shouldn't it be plus 2 that you pull out?
Which
Or
one?
2t
Oh,
plus
yes,
2?
yes, thank you. Very good. Okay, so what we have so far, we have the u1, change it. So f of t will be what? You get the t squared minus 2t plus 2 times u1t. You see? That's what you get so far. So what else do you have to do? You have to manage this one. What do you want, this one? You have the base is 1. Since the base is 1, this inside 1 must be a function of t minus 1. If it's going to be a function of t minus 1, it match your theorem, and you'll be able to find out what's going to be Laplace of t. Any suggestion? How are you going to write t squared minus 2t plus 2 as a function of t minus 1? Yes.
You get t minus 1 squared.
Yes. Very good. But you know that there's just gonna be a little,
Well, find the factored pairs. And then figure out that they
Yeah.
are the same.
okay. In order to get t minus 2 squared, what you need? You need t squared minus 2t plus 1. This is plus 2. So you break it, or you can make completing the square method. Both of them give you the result, okay? So one way to do it is say, oh, this is t squared minus 2t. I break this one into the 1 and 1. Okay, 1 and 1. Now these three parts, this is the one that you are interested in. You get this one? T squared minus 2t plus 1 is t minus 1 squared. So that gives you t minus 1 squared plus 1 times u1t. That's it. You change it to the function of t minus 1. Now it's ready for the theorem. And look the function that you have, you see? Again, this is t minus 1 squared plus 1. You want to find your function. So what you can do is you replace the t minus 1 by t. Okay, by z. It doesn't matter because you shift it. If you replace it by t or by z, it's z squared plus 1. So the function is t squared plus 1 when you do the Laplace transform, okay? So this is easy, this is ready, okay? Any question? So I rewrite it so that you know that you have the format of the theorem. So we change it to the nice u1t times what? Times t minus 1 squared plus 1. You imagine that this is t if you like, or this is z. You call it z or t. So the Laplace of f of t, but because of the u1, it's e to the negative s. Laplace of what? Laplace of function. Function is t squared plus 1. Because you shifted into the t minus 1. Okay, t minus 1 is a name, drop it down, call it z. So the function is z squared plus 1. I want f of 2 is t squared plus 1. Okay, so now we are ready. Laplace of t squared plus 1. So it's going to be e to the negative s. Laplace of t squared again would be what? Would be 2 over s cubed. And the Laplace of 1 is 1 over s. That's it. Multiply inside. So the Laplace of f of t would be 2e to the negative s over s cubed plus e to the negative ss. That would be the Laplace of the, okay, of the given function. Okay, that would take us all to the definition of a function, okay? So the one that you have to use in the theorem is the shifted form, if you like. You have to make it into the t minus c. As soon as you make it t minus c, then you replace t minus c by t, you get your function. And then you'll be able to do the formula. Very useful formula. Okay, any question? I can give you a break now. Because you have to do the inverse one. Okay, so that was the direct one. So we do the inverse one, then we are ready. We are going to go to the differential equation. You have to check. Okay, have your break and we come back. You have to have another group of problem pairs, example. Then eventually we'll give you one differential equation to solve.
I wonder what a partial differential equation looks like. Aren't those really bad?
What do you want?
Or I was wondering what partial differential equations look like. Are they really bad?
Yes, they are. No, in fact, everything we have in science is partial differential equation.
Oh, fun.
It takes time to solve it. So we are going to see how we're going to do it the other way around. Okay, because this is the way we are going to use it when we get to differential equation. Okay, so this is going to be the second group of the example. So example. In this form, we want to do the other way around, find the inverse. Okay, find the inverse Laplace transform, okay? Inverse Laplace transform of each function. Each function. It's very easy to identify that. You have to use this method that we talk about it. Okay, so we go with the first one. The first one is this. The function is f of s equal to f of s is equal to the 2e to the, okay, e to the negative 2s, e to the negative 2s over s squared plus 4. You see, as soon as you see that e to the negative 2s, you realize that this must be done by the translation theorem that we talked about. So the formula that you have to use is this one. See, the Laplace inverse. So Laplace inverse. Okay, that's it. Laplace inverse of e to the negative cs. Okay, negative cs fs is going to be equal to the UCT. Okay, it's going to be equal to the UCT f of t minus c. Okay, or sometimes they write it down in this form. Okay, the format is, if you want to find the Laplace inverse of e to the negative cs fs, what we do is we are going to have a factor of UCT over here. So we are going to forget about UCT. We're going to find the Laplace inverse of this function. You find it. Find the Laplace inverse of the leftover, which is going to be f of s. And this function will be a function of t. And in the formula, you should have t minus c. So when you find it, you replace the t by t minus c. That's the way we are going to do it. And we want to do the action, if you like. Okay, as soon as you see the factor of e to the negative cs, this should be done by the translation theorem. So this means the function would have a factor of UCT. And if you have the factor of UCT, remember the leftover must be f of t minus c, which means you forget about e to the negative cs. You find the Laplace inverse of the leftover function. When you find that, the result will be f of t, and you need t minus c. So you're going to find it first, then you replace the t by t minus c. That gives you the final answer, okay? So first, they are always going to be together. Then we go into differential equation, then you put them together nicely. At the end, you have one part that it's is f of s, the other part will be e to the negative cs. But this is easy now. We go back to that. Okay. So this is the way we're going to solve it. Say Laplace inverse. Laplace inverse of f of s is going to be equal to, okay, I'm going to break this one so that you can see it. We want to find the Laplace inverse of e to the negative 2s times 2s squared plus 4. See? Because of e to the negative 2s, you are going to have u2t. So it's a u2t, now you find the Laplace inverse of this function. You find the Laplace inverse of s over s squared plus 4. But when you find it, you replace the t by t minus 2. Because you have to shift it to get this done. Now this is easy to find. What is this? Laplace inverse of s over s squared plus 4. Cosine of 2t. So this is going to be equal to the u2t cosine of the 2t. But you have to change the t into t minus 2. Okay, in this part, of course, only. Okay, so the final answer would be what? I'm sorry, this is, I made a mistake here. And that is true, okay? That's a true, I write down it says, let's stay with the true. That's it, true. If it's gonna be true, this is gonna be sine, okay? Sine of the 2t. We're gonna stay within our previous one with cosine. So it's gonna be 2 over s squared plus 4, which is gonna be sine of the 2t, but you have to change the t into the t minus 2. So the final answer, Laplace inverse of the given function is equal to u2t, the sine of 2t, but 2 times you change the t into the t minus 2. So this is the way you are going to write the final answer. Okay, keep it in this format, it will be easy. Depends what you are going to have the leftovers. We have to use the partial fraction, all the other formulas that we have to apply. But the only thing that you have to do is you have to take that unit as step function out. Unit the step function out, you get the function, then you shift it into t minus 2. Any question? That's the first one. Okay, so as soon as you see the e to the negative 2s, you know that you have to use unit as step function. So that would change into the UCT. Then for the leftover, you find the Laplace inverse first. It's going to be a function of t, but remember, it did have shifted. UCT f of t minus 2. So that's why you have to change the t into the t minus 2. You did it the opposite. Remember when it was this case, I called t minus 2 z, if you remember, the way we did it. So this is case 1. Just give you one more, and then we go to the differential equation because we're going to do it over there too. So the other famous one or popular one is this one. Suppose you have e to the, e to the, 2ss, let's say e to the note that I'm going to post it for you, it's going to be 2s. E to the negative 2s again, and that's going to be s squared plus s minus 2. Let's find the Laplace inverse of this function. Again, you see that factor? That will tell you that you have to use unit step function. So, solution. So we'd like to find the Laplace inverse of f of s. You can do it right away or just remind yourself that I'm going to rewrite this one as e to the negative 2s, 1 over s squared plus s minus 2. So far, this is going to be equal to, because of e to the negative 2s, I have u2t. Then I have to find the Laplace inverse of 1 over s squared plus s minus 2. When I got it, then I change the t into t minus 2. It's coincident, both of them are t minus 2. Okay, so we have to work on this one. We did it as we did it before. So the question now is going to be, what is Laplace inverse of 1 over s plus s squared plus s minus 2? You know that you have to factor it because it's factorable. So it is going to be 1 over, what is that? It's going to be s plus 2 times s minus 1. It's not going to be s plus 2 and the s minus 1. Again, there is no constant on the top. So you can use two opposite numbers to start with. You can write 1, negative 1. It doesn't matter which position. Now check it. 1 times s minus 1 would be s minus 1 on the top. Negative 1 times this would be negative s minus 2. This would cancel out, that give you negative 3. But you need the 1 here. So what you do, you go back and you divide this by negative 3. So that would be divided by negative 3, and that would be divided by negative 3. So I'm going to rewrite it. Okay, so basically this would be changing to the 1/3 over s plus 2 minus 1/3 over s minus 1. The Laplace inverse is easy to find, the exponential function. E to the t Okay, any question? So take the Laplace inverse of this and then change it to the t minus 2, then you that. And you are going to use it quite a lot. Okay, so I go to the next page. I rewrite this one, so that give me 1/3 e to the negative 2t minus e to the, okay, t, yes.
Wouldn't it be negative 1/3 over s plus t? And then on the other one, the two negatives would cancel out, so then it would still be plus.
What's that again?
So if we divide it by.
See, I did have this, I divide by negative 3, okay?
Mhm.
So this is, yeah, this is negative, yes. This is negative, the other one positive, okay, now that's correct. So this will cancel out, you get the 1/3 and the 2/3, 3/3, yeah, thank you. Okay, so let's check the Laplace inverse. So Laplace inverse of, so the Laplace inverse of 1 over s squared plus s minus 2 is going to be equal to, okay, so the first, I just check it. The first one is negative, the other one is positive. So it's going to be negative 1/3. Okay, negative 1/3 e to the, okay, negative 1/3 e to the negative 2, okay, negative 2t, and positive 1/3 e to the t. Okay, that's in fact your f of t, if you like. And you have to change it into what? You have to change the t into the t minus 2. So this is it, you change the t into t minus 2, and you rewrite it again. So eventually, this is going to be the final answer. So the Laplace inverse of the given function, which was e to the negative 2s over s squared plus s minus 2 is equal to, we get the unit step function of the u2t. Now times it by this function, but you have to change the t into the t minus 2. It's going to be negative 1/3 e to the negative 2 times t minus 2. Okay, plus 1/3 e to the t minus 2. So that would be the final answer. Sometimes we call this one g of t and then we write the answer as g of t minus 2. And these are short for the time being, so we have to repeat it. Okay, any question? So the inverse is easy to locate because that factor that you will see, the factor of e to the negative s2, s3s, that will guide you how you're going to change it. Okay, so what is going to be the price? The price is going to be, we can wait to solve the differential equation, but we would like to see one of them right away. And there you are. This is going to be type 2 of the differential equation. On the test, you get type 1, the one that you did on this quiz. The type 2 would be of this type, okay? And it's not going to be 100 type. So example, you want to solve a differential equation, of course, by Laplace transform. You have no other choice for this one. I don't need to say that Laplace transform. Okay, so solve the equation. Solve the differential equation. Differential equation. See, this is the type that you may see in application problem inside. You have y double prime plus 4y equal to is equal to, just check to see, make sure we are able to do it. Yes, we can do it. So it's equal to the sine t minus u 2 pi t sine of t minus 2 pi. This is the differential equation. Of course, we have initial condition. Initial condition of y of 0 is equal to the 0, and y prime of 0 is also equal to this. That's it. So you will see this type of function, you have no other choice other than the Laplace transform. It seems to be unusual, but it can be done. Okay, it can be done. Are you ready?
Is that 2 pi?
Pi, yes, yes. Yeah, the base is 2 pi. When you are in application problem, the base is pi, 2 pi, pi 4, 2 pi 4, etc. Okay, go as usual. Take a function and just take the Laplace transform on both sides. Do it. You have to get the algebra done, and eventually we get one of those functions, and we have to find the Laplace series. Okay, are you ready? So I don't like this notation. I change it into the f of t. So suppose y equal to the f of t is the solution. Okay, suppose this is going to be the solution with initial condition. I rewrite the initial condition in terms of the f of 0 is equal to the 0, and f prime of 0 is equal to this. Okay, so I change it. So take the Laplace transform on both sides, one by one. This is it. You have the Laplace of, so this is a situation that we have. So the Laplace of f double prime of t plus 4 times Laplace of f of t equal to, remember both sides of the equation. Both sides that give a Laplace of sine t, Laplace of sine t minus Laplace of u 2 pi t sine of t minus 2 pi. Okay. I'll use the formula to change this one. F double prime, remember the formula? So it's going to be what? Start with the s squared Laplace of f of t. We reduce the power of the s, we bring those f of zeros. So it's going to be minus s f of 0. Okay, minus f prime of 0. That's formula for the first part. Plus 4 times Laplace of f of t for Laplace of f of t. Now the other side. Laplace of sine t. You know, the Laplace of sine t is what? It's going to be 1 over s squared plus 1. That's the Laplace of sine. Minus, you see this one? This is just the translation theorem. It's like UCT, remember UCT, f of t minus c. Because of the UCT, you have a factor of e to the what? Negative cs.
Negative 2 pi.
Negative 2 pi s. 2 pi s. Then a Laplace of the function. We replace the t minus 2 pi by t is the Laplace of sine t on. Okay, Laplace of sine t, which is going to be 1 over s squared plus 1. That was the formula that we talked about. Because of the UCT, you have the e to the negative cs. Okay, and because of the function, this is the shifting. This is, you call t minus 2 pi t. So the function is sine t. Sine t, the Laplace of sine t is going to be 1 over s squared plus 1. Okay, any question? Continue simplify this, bring the initial conditions. Initial condition f of 0 is 0. Okay, f of 0 is 0. And you have f prime of 0 is 0. So that make it easy. This would be 0. This would be 0. Okay, so for the leftover, we usually factor out. So you factor out that Laplace of f of t. So it'll give you s squared plus 4. S squared plus 4 Laplace of f of t. There is no leftover. You go to the other side. We have 1 over s squared plus 1 minus e to the negative 2 pi s over s squared plus 1. Okay, this is the case. Now divide by s squared plus 4. You divide it as is. Don't shrink it. Don't find the common denominator or anything. Just do as is. Okay, so this is going to be Laplace of, so it's going to be Laplace of f of t is equal to, you divide by the first one, it's going to be 1 over s squared plus 1 times s squared plus 4. It's going to be minus e to the negative 2 pi s, okay, 2 pi s, and this is going to be s squared plus 1 times s squared plus 4. Okay, so this is going to be the case. Okay, now get the Laplace inverse to get f of t. So what's going to be f of t? F of t is equal to the Laplace inverse of the first one, 1 over s squared plus 1 times s squared plus 4. See, the next function is just the unit step function version of this one. We have Laplace inverse of what? E to the, I rewrite it in this form, e to the negative 2 pi s, 1 over s squared plus 1 times s squared plus 4. See, that's going to be the case. Now, if you find the first one, automatically you can get the second one right away. You see, for the second one, you know that there's going to be a factor. Okay, going to be the factor of the, what's that? Factor of u 2 pi t. It's going to be u 2 pi t. You find the Laplace inverse of this, and you change the t into the t minus 2 pi. And you have it here already. It's always the case. In the case of the differential equation, so we find this one first. As soon as you find it, then you can use it for the second one and the unit step function, and they do that. Okay, they are always the same thing. So let's check this one first. You know that to get this one, you have to use the partial fraction and the usual one that we have. Okay, you break it and get those numbers. So this is it. You just work on this. We did it before. S squared plus 1 times s squared plus 4. Again, those short form that we just did. S squared plus 1. Okay, s squared plus 4. Those 1 negative 1. This is the one that exactly I did. So this is the 1/3 and the negative 1/3. I think that would be okay. Negative, yeah. All this, you know, it doesn't matter. That should do it. Okay, you get 1 and negative 1. Again, you divide by 3. You would say. So if you cross multiply, now the negative 1/3 s squared. These two will cancel out. That give you negative 4/3 plus 1/3, which is 1. Okay, that's shortcut that we have. Any question? Now get the Laplace inverse. So what's going to be Laplace inverse of this? So the Laplace inverse of 1 over s squared plus 1 times s squared plus 4 is going to be equal to the first one is a negative 1/3 sine of t plus 1/3. Okay. We need one there. It's going to be 1/3. We have, we want to write the sign. We need a 2 on the top. Okay. Let me just, that's going to be the case. Because this is s squared plus 4, you have the a, which is 2 on the top. So it's going to be 1/2 sine of the 2t. Okay, because for the sine, you should have a over s squared plus 4. So you need on the 2 on the top. So we divide by 2 and multiply by 2 as we did it all the time. So the final answer for this is going to be negative 1/3. Negative 1/3 sine of t plus 1/6 sine of 2t. That is going to be this is going to be the first part. Any question? Now, sometimes we make it short. Okay, we accept it if you did. So I'm going to call this one, so I don't want to repeat it again. I'm going to call this one g of t, if you like. I call this one g of t because I want to take it to the second part. You can do this type of formula, we accept it. Okay, so what I am going to do now, I have to find the second one. What is the second one? You have the unit step function u2 pi t, Laplace inverse of this function when you change the t into the t minus 2 pi. The Laplace inverse is g of t. So we just change the t into t2 pi. You know, this is the way we quickly write it down. Otherwise, if you don't like it, list it. Okay, it's going to be aligned. List to write it down. Okay, so this is it. So I repeat it again. So I use that formula to show you. This is the one that I did. S squared plus 4. This is the one I call it G of t. Okay, G of t. So the Laplace inverse of the second one, e to the negative 2 pi s 1 over s squared plus 1 times s squared plus 4. This will be what? Would be u 2 pi t times g of, okay, it's going to be g of t when you change the t into the t minus 2 pi. Okay, it's going to be g of t when you change the t into the t minus 2 pi. So in short, this is going to be u 2 pi t times g of t minus 2 pi. You don't have to repeat it if you write in terms of the g. If you don't like it, list it and use the formula. So in this form, the final answer is f of t equal to the g of t. Remember when we break it into parts, there's a negative sign in between. G of t minus u 2 pi t, g of t minus 2 pi. And you have to tell us what is g. When g of t is what? G of t is a negative 1/6. Sine of the 2t plus 1/3 sine of the t. You can use this brief version of the formula because there are going to be quite a lot when you do go through this differential equation. So this is customary to put it, kind of condensed form. If you don't like it, you list it. Okay, yes.
So is Laplace transform supposed to be like a quicker method of what we did before, or is it
It's quicker.
is it meant to like,
Can you solve
Solve.
this differential equation without Laplace transform? The question is this.
so it can solve more complex differential equations than the methods we had
because
before?
these are the type that you will see in application problem. You see the one that you did, this equation, it's not possible to do any other method. Because this is what? This is the second order differential equation, non-homogeneous one. The best you can do is what? Solve the homogeneous one first. Then you have to find the YP. Remember, particular solution. So you can, what are the choices for the YP? The choices what the YP is and determinant coefficient only if the function, remember, polynomials, exponential, sine, cosine, or variation of the parameter. And for this type of functions, you better not do it. That's why. Because it's this is a piecewise defined function. That's the difficulty. So that's the role of the Laplace transform going this side forward. When you do a couple of them, you quickly, they are repeated. They have a very special format. But anyway, it's a tool. It's a tool, but for this problem, you have no other choice. That's why I don't have to tell you that apply the Laplace transform to solve this problem, because you have no other choice, okay? But it can be done.